Okay, well, thank you for introducing me. Actually, this is a paper I wrote together with Rob Boshuizen, so that's why I mentioned his name here as well. Even hard to pronunciate. Boshuizen, right? Yes, that's the way you pronounce it. Yeah, I can leave it to you. Okay, fine. Okay, this paper is about algorithms and also about mindsets behind algorithms, and then how to deal with this in education. That are the last two paragraphs, the last two sections of this presentation. So, what is it all about? The idea is that there is a relationship between algorithms on the one hand and underlying mindsets on the other one. And these mindsets play a hidden but crucial role in practicing algorithms. And since in society there's a growing importance of algorithms, we think that it's important to give attention to this fact, to pay attention to this fact in academic education. And therefore we introduce a special way to educate not only about algorithms, but more general. You can also use this method in science in general. So that is the main idea of my paper. Just a few questions on this first slide. So many people speak about algorithms and big data as if this is objective information, if this come and fall from heaven directly. We can also think more critically about the data. Is our data discovered, that just pull away a curtain and then you see how reality is, or are data constructed in some way? Are they manufactured? And are they dependent on certain assumptions? Now, we think yes, and we call these assumptions part of an underlying mindset. Also, data is ordered in categories, and also these categories are not totally taken for granted. Also here are decisions important, and these decisions you don't see when you use algorithms, and therefore it's important to give attention, to pay attention to algorithms and the way they are constructed. So that's the main topic. Oh, okay, there's something wrong here with this presentation. I go to the next slide and give you an example. And that example is e-court. Maybe you've heard of this. Normally, if there is a case, a law case, you have a real human judge, and they need to make all kinds of decisions. Now, e-court is a recent phenomenon in which artificial intelligence is used to render verdicts. So in this has some advantages. So many law cases are a bit equal. Hey, you buy something on the internet, something went wrong, you have some discussion with the company, between the client and company, and there is a judge needed to force a decision. Now, there are a lot of these similar cases, so then it's efficient to use e-court to have artificial intelligence to render these verdicts. Another advantage is that many people think that an e-court is more impartial and there are no subjective influences, because normally judges are human beings and they have their own sympathies as well. And if you know a bit about how it's going on in law, now my son is studying law, so we have nice discussions about this. For example, to run a verdict in the Netherlands, it's sufficient to have 2 independent pieces of evidence, and you can even ignore all other parts of evidence. Well, this gives a lot of problems, and here the choice of the judge which pieces of evidence to take is very important. So maybe e-court is a nice idea if you can rule out this impartiality and this subjective influences. So in one way, it's a very big advantage that e-court is introduced. Okay, I don't know what happens. Something wrong. So there are also advantages of the big data. You can easily make patterns made visible, and maybe they are more impartial, more independent than normal patterns described by human beings, let's say. So for example, a consumer's information may improve a lot. I was looking for some interest in some windproof jacket that could be was breathable as well. And then, of course, by internet, I could easily find a lot of jackets, make a comparison, and make a decision. And this is also possible with big data, and you don't need a lot of time to do that instead of going next to all the shops and visiting all the shops. But sometimes it doesn't work as easy as this. So, for example, I read a lot of books, and if you order the book about the First World War, then the website also gives you other suggestions, like books you may find interesting. First of all, they think I'm only reading books about the First World War, so that's a kind of mistake. But also, it's difficult to find a right match. So the author, the theme, the genre, that's okay. But books differ in style and tone and taste, and so it's not so easy for an algorithm to give suggestions that might be useful. So algorithms are not always working the way you would like them to work. Now, it could be a possible solution. For example, you can say, well, anyway, if the technology is improving, we can analyze information better, and then algorithms will work out well or perfectly well in the future. Might be. Others say, well, maybe algorithms are necessarily subjected to certain limits, and it is impossible to go beyond these limits. And maybe in e-court, this is something that plays an important role. So, well, if you think about random verdicts, it seems that these verdicts are based on rules and procedures. And these rules and procedures could be subject to an algorithm. And then algorithms could perfectly well render a verdict. But is this the case? So, yes, if this is the case, then algorithms are an option. But I learned from my son in his law school that, for example, a difference between now and 20 years ago is that also in rendering a verdict, the judge looks at what is our convenient thoughts in society. And this is, of course, object to change. So this is one reason why a judge needs to make also a kind of a judgment, a human decision. Also, we have, I don't know how to call it in English, is jurisprediction. So based on all kinds of law books, we have new verdicts, and these new verdicts are also taken into account when a new case occurs. So point is that it's not so easy to base a judicial verdict only on rules and procedures. More seems to be necessary. And that is why some people say, well, you also need maxims such as justice and fairness. So the law book is not sufficient to render a verdict. You always have to think, okay, what's in the law book, is that still seen as being justified? Is it fair what the law book is telling us? And this is a kind of evaluation, is a typical human evaluation. So we seem to need also what I now will call judgmental rationality, and that's different from algorithmic rationality. So a human being seems to be necessary to make deliberations, to make human arguments. So my point is that algorithms are not coming from heaven, but that mindsets are important assumptions underlying these algorithms that determine the results. And I use, for this kind of idea, the picture of an iceberg. Algorithms, you can say, are there on the surface, and the results are above the surface. But in some way, these results are determined by underlying factors like professional and personal interests, politics, economics, society. They all influence the way an algorithm is constructed. Well, this is, I think, the conclusion for e-court. I'm not going to read this whole conclusion, but the idea is that algorithm does not unambiguously emerge from the analysis of big data, but that there are invisible parameters, indicators and criteria that are necessary to render a verdict. So our claim is that mindsets play an important role. And these mindsets also play an important role while thinking about science. That's the way, that's my part of my research. So in science and in algorithms, theoretical perspectives may play a role, models and methods may play a role, disciplinary principles and contextual factors, ideas about the structure of reality, the boundaries of science, and in addition, even moral values, views of man, anthropological views, normative ideas about the structure of society, all can play a role while constructing an algorithm. So now I come to education. We think it is important to educate students about this fact, not only to teach them how to practice all kinds of computer stuff, but also to think reflectively about the way algorithms are constructed. And therefore we developed a kind of method, or we developed it earlier, and now we try to apply it to algorithms. That's dilemma-oriented learning methods. So we think that it's important to pay attention to the fact that mindset play a role. And the first way to do this in education is to demonstrating of examples, how equal works, consumers information, etc. Another way, and maybe more important, is trying to stimulate reflexivity in students themselves. So also the students have their own perspective. And that's also important when they evaluate an algorithm. An algorithm is constructed based on some mindset. So how to reflect on that. And that's not so easy. And therefore we developed this method, the dilemma-oriented learning model. And we also developed, as a second part of it, the learning results-based development model that try to stimulate teachers and students to improve the way the learning model works. I will be short about this last point. So let's dig a bit more into the dilemma-oriented learning model. Now, DOLM exists of 4 phases. The first is reflection on intuitive ideas. Then in the second one, reflection on relevant scientific knowledge. Then we call this the philosophical reflection. And then the retrospective phase. The main goals of DOLM are that students are able to deal with complex problems in the context of interrelated scientific, societal, worldview, philosophical and ethical aspects in a critical, balanced and responsible way. Critical is defined as taking into account their own frames of reference, their own mindsets, as well as the underlying pre-scientific assumptions. So this asks quite a lot of them. Balanced is that you take into account a critical and thorough assessment of arguments for and against. So students demonstrate sympathy and respect for opposing arguments. Here, dialogue also plays an important role. Not only are they reading and studying different perspectives in literature, but also listening and learning from each other. And the last is then that after being critical, after being balanced, they have to come to responsible choice, and showing their willingness, ability, and motivation to account for the choices and courses of action in the reports or communication. And this is a complicated picture of how the dilemma-oriented learning model works. On the left, you see the 4 different phases, and in every phase there is a job of clarifying new positions, weighting all kinds of arguments, making choices, communicating with all the students, and this holds for every phase. Now let's go to an example, because it's quite abstract until now, and go to an example regarding algorithms. Maybe some of you know this book of Katie O'Neill, Weapons of Mass Destruction. It's a very nice read, but also a bit confronting, because one of the examples she tells is about the story of poor performing schools and the dismissal of hundreds of teachers. So the point is that this dismissal was based on an algorithm-based assessment tool for teachers called Impact. And this algorithm showed that some of the teachers in the school were underperforming, and that was the reason why they were dismissed. Now the question and the dilemma for the students is Sarah's dismissal, Sarah is one of these teachers, is her dismissal justified or unjustified, and why? And that's the dilemma students are confronted with. And in this dilemma, we go along these 4 phases of the model. Well, in the first phase, the idea is that the students, without any further information, just think about about the case of Sarah. Just the intuitive ideas, own experiences come into account here. And the teacher, of course, can also help the students by introducing dilemmas, theses about this case. So, for example, one could say the decision is accepted because it was based on algorithms, and algorithms are seen as objective and reliable. That's exactly how the dismissal worked. It was based on an algorithm, and of course, there is, to say something, in advantage of this decision. Other people, knowing, for example, the way e-court works, say, well, decision is not accepted because, indeed, according to the algorithm, Sarah was performing badly. But according to the opinion of parents and the school management, who had a more subjective idea about Sarah, they said, no, she's doing quite well. We're all positive reports. So that might be a reason to overrule the argument. So here there is a real dilemma for the students. I had to tell this while introducing the case. Well, then the students are going to read some scientific information about this case. And there are different experts consulted. And this helps understand students to assess and evaluate the different scientific theories that are used in the arguments presented. Well, some scientists may, of course, defend the way the impact algorithm assessment works, and may argue that this tool gives a more objective opinion if you consider the opinion of school leaders and parents, if you compare the idea of the result of the algorithm with these opinions. And of course, this is a point. Other experts show that the impact was only based on 25 to 30 students, so that's a small number. And then you can imagine that if you take another group of students, and the outcome could be different. So here's the reliability problem. Maybe the most interesting problem is the concerns about the validity, because you can imagine that another teacher who was not dismissed did quite well, but it was not totally dependent on the way Sarah and this other teacher were teaching. Because what also is important, that is the way the students or pupils were acting in primary school. If the results of the students of Sarah were quite bad at primary school, then it's logical that her teachings had results that were not as good as colleagues who had students from primary school who were doing quite good over there. So that's a problem of validity. And does your conclusion really follow from the facts? Or do you need to have to do a pre-test to know what the level of the students is when they start studying in high school? Now in phase C, you also think about all kinds of more philosophical problems regarding the workings of algorithms. And for example, you can, of course, think about a problem of objectivity. The philosophers really like to discuss the concept of objectivity. And for example, I have an article with a colleague about the value-free idea of science, which is still quite popular, but from a philosophical perspective, you can really criticize this idea. So objectivity, is it really a concept you can use in case of algorithms and in case of science in general? Another interesting point is the level of analysis. So here in this example, the individual teachers were blamed for the bad results of badly performing students. You can also think about another level. The educational system in the country can also be blamed for this result. So what is the level of analysis? Individual teachers or the educational system? Here also decisions need to be made, and it is becoming a real philosophical problem if you try to reduce the second level to the first one. So sometimes in social science, people try to reduce the collective level of institutions to the individual psychological level of the individuals forming the society. Then also ethical deliberations can be taken into account because now the result of the analysis, let's suppose that the algorithms works fine, students were badly performing, it was Sarah to blame for it. So why dismiss Sarah? You could also say, offer her some education to increase the level of teaching. So there's also an ethical decision to make over here, and that also falls under fast C. Now, fast D is meant to let the student think about their developments. So they made a choice in fast A, fast B, and fast C. What was the important factor, the crucial factor why they made their decision, and was there a kind of development that's done in this last phase? Now I have to hurry up a bit, so I show only this last picture. So you can construct such a course, and it might be work in theory, but if it doesn't work in practice, you always have to evaluate your course and try to improve it. And in this evaluation, the design of the course, the teaching of the course, the students are all working together. That's the presentation of this last picture, and I hope I'm just in time to finish it. Okay. Thank you for your attention.
Well, thank you, Edwin.